Hello, everyone, and welcome back. You've completed group 2, and now you're on to group 3. I just want to say a few words before you move forward. So you are becoming an expert in your own uncertainty, and you will learn through this process to provide accurate estimates for our model building procedures. So before we move on to group 3, just think about your process in group 2. Talk about any thoughts, feelings, or doubts, write them down or share with a neighbor, share with the team. And I want to give you a few hints. And these hints are on the don'ts of calibration. So this is not a trivia test. Okay, it's a way, what we're trying to do is assess uncertainty, understand variability, and try to get accurate estimates for projections in our model. We want to know based on your level of knowledge, but not to test you for trivia. And don't assume that wide ranges are terrible. If they really represent your uncertainty, if you don't know, then a range should be quite wide, and a narrower range is not more correct. We don't want to end up with very narrow ranges, but they miss the target as we saw in the previous slides. And don't think of it as we're not guessing here. It's not a guess. We will see improvements. Improvement is measurable. People can get better at providing accurate estimates. And one of the ways you can do that is to make use of some cognitive tools. And I want to introduce one here that works really well for me. It's called the equivalent bet. So when I'm providing numbers for a distribution, upper and lower bound for a distribution, then I can try to provide those numbers based on this little tool. So we're always asking, of course, for a 90% confidence interval. And for the 90% confidence interval, would you rather have, if you stood to win 1,000 euros, money on the table usually helps switch on system 1 and get us to focus a little more. So would you rather, if 1,000 euros is on the table, would you rather your distribution with a 90% chance of winning and a 10% chance of losing? Of course, because it's a 90% confidence interval that you've defined. Or would you rather spin the dial? And if we spin this dial, depending on where it lands, 10% of the area here is win 0, but 90% is win something. Would you rather spin this dial and leave your chances to that dial? Or would you rather have your distribution? And this, of course, should be the same. You should feel more or less the same about the two. And typically, generally, you're probably in the case that you would rather spin the dial. That you're unsure about your distribution, you don't know if the true value is there, you can't be certain, you wouldn't want to win that money from your distribution, you'd rather choose the spin the dial. 90% chance of winning 1,000 euros over there. So typically, what we've expressed in those distributions, what you've expressed so far in those distributions is too narrow. And you should widen that distribution until you feel that it matches your perception of the win 1,000 euros with the spin the dial. So that's something I use a lot when I'm trying to provide distributions. It helps me a lot in thinking about my upper and lower bounds and thinking about the distribution and how well it describes my uncertainty and the expected variability of those values. And now you're going to move on to group 3, another set of questions, and we'll check back again when you're done there. Enjoy.